Hello, my name is David Nagy and I'm gonna give a hands-on lectures about GIS. What this lesson gonna cover is a short description of what GIS is, how to use GIS in the soil science, and what GIS software is available for you to process these datasets which you have gathered in the previous classes. I'm gonna give an introduction that's how to set up for the lesson, and we're gonna execute an exercise together based on those field measurements which you have previously done in this course. So what geographical information system is basically working every kind of data which already spatially referenced. So it has coordinate system within like attached to a coordinate system. It can be land management data, social data, environmental data, and especially in our case water content data, soil texture distribution, electrical conductivity, climate data such as precipitation or wind, and also topography measurements as well. The basic GIS features are rasters and vectors, which we're mainly gonna working with. Raster is a grid-based data set, so cell by cell only one information are stored within the data set. The vector is a different one. It's within its features behind several information can be stored. It's a very accurate representation of the real world, so it's very nice to use later on for cartography purposes. So as I told, it's an original resolution. It keeps of the real form, aesthetic as well, but the disadvantage that continuous data are not really effectively can represent it within the data with vector data sets, and also spatially analysis is very hard to use with vector polygons. Raster, it's on the other side, is a cell by cell location. It's very easy to do geocomputations and calculations, and also adequately can represent continuous data and also discrete data as well, such as piezometer measurements or borehole measurements as well. The problem that the cell sizes delimit the sizes of the field, so the resolution can be very bad sometimes, and also it's very not adequately represent light feature due to it's a grid-based cell. Yeah, and it's not really good use actually for cartography purposes as well. What we're going to use in this class: TDR measurements, the time domain reflectometer measurements, the electromagnetic measurements from the field which you have done before. We're going to use satellite imagery just for locate the field using the satellite image, and also to introduce this point soil texture measurement which you have done previously also in this class. The existing type of GIS software which is available for you is ArcGIS and QGIS. ArcGIS is a commercial based software. That's what we're using here in this class. However, if you would like to download something similar for your own desktop, it's QGIS. It's a freeware software, and it's the same quality of data manipulation you can done between, like the same can be done in the two software. The instructions to how to get set up for this lesson: we're gonna give us your TDR data, your EMI data sets, and RVI data sets which was measured before your course. You have to provide the general statistics that to see that how to can understand what kind of distribution you have within your data set. Provide a histogram, for example. You also have to visualize that kind of what kind of spatial distribution you have within your soil data, and later on I'm going to introduce a more advanced technique to use Kriging interpolation, which you can interpolate between 2 points which you have measured, and basically create a continuous data set for whole field, so you can basically see the spread of your data, how it's actually located, like two-dimensionally. By the evaluation of the class, you have to prepare a maps based on your given data sets as it's seen in the left, and you have to assess your result with your neighbors, and later on at the very end of the class, please make a 1-minute paper with your main interpretation of your maps. So kind of try to describe that how you would like to understand what you have created. Thank you.